All right, this video is over section 3.3, complex numbers. So before we start, we need to talk about the imaginary number I, and this comes into play whenever we have to square root a negative number. So first off, I is equal to the square root of -1, and consequently, if we were to square both sides, I squared is equal to -1. If you were to try this in your calculator, you cannot square root -1, and so we have to have a way to deal with that, and we like to use the placeholder I. Another point here is that if b is a positive real number, then the square root of -b would be I square root b. So we took that square root of -1 out and made it into an I. The other vocabulary words we'll come back to. So let's go ahead and start working some problems. So down here we have the square root of -25. I'm going to show all my work to start, but I think you'll get it pretty quick. So if I was to break down -25, I could break that into -1 times 25. And both of these square root perfectly. The square root of -1 would be I, and the square root of 25 would be 5. It looks kind of weird to write I5, so we're going to write our solution as 5i. Next, we have the square root of -32. Now, the 32 does not square root perfectly, but we can still simplify this. So we're going to break this out into -1 times 16 times 2. The square root of 16 does simplify perfectly. So we can square root out that -1 and the 16. And so on the outside of our square root, we're going to have 4i. But the square root of 2 does not come out perfectly, so our answer is going to be 4i square root 2. This last one, we can break this down into -1 times 2, where the square root of -1 comes out to be I. The square root of 2 is irrational, so we leave it, and our answer is I square root 2. All right, for this next section, we're going to do the same thing, but we're going to multiply and divide as well. Now, you can either multiply and divide and then simplify, or simplify and then multiply and divide. I'm going to do that. I'm going to simplify first. So here, if I break down the square root of -36, the square root of the negative would be I, the square root of 36 would be 6, so this would just be 6i. And similarly, the square root of -100 would be 10i. When I multiply these together, I get 60i squared. And then back at the top, when we were talking about I squared right here, we have that I squared is equal to -1. So if we take that and apply it here, this is going to be equal to 60 times -1, or -60. All right, for this next one, we have the square root of 15 times the square root of 3. And they both have the negative, so I'm going to go ahead and take out an I. And 15 does not simplify, so I'm going to leave that inside. And I'm also going to take out an I. And the square root of 3 does not simplify, so I'm going to leave those inside. Now this one is a little bit trickier. We still have I squared on the outside because I times I. And then on the inside, we're going to have 15 times 3, which is 45. Now we know from the last problem that I squared is equal to -1. So I'm going to come up here and put -1. And then the square root of 45 does not square root perfectly, but 9 times 5 is equal to 45, and 9 does square root perfectly. So on the outside, we're going to have negative, and then now it's going to be a 3 because of the square root of 9, and we're left with square root 5 on the inside. And just remember here, we changed I squared to -1. All right, for this last one in this section, we can simplify the top into -1 times 9 times 2. The square root of 18 does not simplify perfectly, but 9 does. And then on the bottom, we can do the square root of -1 times 2. And so when we take the square root of -1, we're going to have I. And when we take the square root of 9, we're going to have 3. So I'm going to put the 3 in front and make that 3i. And the square root of 2 does not come out perfectly. It is irrational. And then on the bottom, we can also take out that square root of -1 and make it into an I as well. And the square root 2 is irrational, so it stays. Now here this looks kind of weird, but if you don't think too hard about it, you can go back to Algebra 1 and see the i's cancel out, the square root 2's cancel out, so this one is just simply 3. Now I'm going to use a different color, but really quick from the beginning, we could have divided this out and we could have had the square root of negative 18 over negative 2, which would have been the square root of just 9, which would have just given us 3 quickly, but I did want to break down all the i's and stuff for you. Awesome. Okay, for this next part, we need to jump up and talk about complex numbers. So given real numbers a and b, a complex number is written in the form a plus bi. And the real part of a complex number would be the a, and the imaginary part would be the b, I. I guess it would just, hold on, I guess it's going to be, let's just be the b, because of the bi, the imaginary number I. Okay, so let's go work this next section. It says simplify each expression and write the result in the form of a plus bi. So we have the square root of negative 81. And we know that the square root of 81 is 9. The square root of the negative 1 would be I, so this would be 2 minus 9i. And this is already written in the form of a plus bi. Let me change colors real quick so you can see that. So for this problem, our a would be 2 and our b would be negative 9. So not important, but just so you can see that it is in the form a plus bi. All right, for this middle problem, we already have the I here, so we don't really need to simplify. However, we have this 3 on the bottom, so we need to divide 2 by 3, and we're going to get 2/3. And then we need to divide negative 5i by 3, so this is just going to be minus 5/3 I. And now it's in the form a plus bi, so for this one, a is 2/3, and b would be the negative 5/3. All right, for the last one, we do need to simplify the fraction and that negative square root of 48. So this is equal to 4 plus the square root of negative 1 times 16 times 3 all over 12. And so if I square root that, I have 4i. So this would be 4 plus 4i. Square root 3 is irrational over 12. So all I did was take out the square root of negative 1 to be I and the square root of 16 to be 4. And then here we can divide out the 12. So we'll take 4 out divided by 12 and then 4i square root 3 divided by 12 as well. And so we are going to have 4 over 12 plus 4i over 12 square root 3. And we want to simplify the 4 over 12 parts to 1/3. And then we do want it to look like a plus bi, so we're going to keep this 1/3 plus square root of 3 over 3 I. So that would make a is 1/3 and b is square root 3 over 3. All right. So this next section says add or subtract as indicated and then write the answer in the form a plus bi. So for this, we need to distribute this negative, and we're going to have 4 minus 2i minus 3 minus 7i, and then this is easy as combining like terms. So our 4 and our minus 3 together go together, our negative 2i and our negative 7i go together, and we are left with 1 minus 9i, and we have our a is 1 and our b is negative 9. For this next one, we're adding, so there's nothing to distribute. We can just go straight to combining. 5 and 2 are like terms. 3i and negative 6i are like terms, so our answer here would be 7 minus 3i. Same for this next section, except we are going to be multiplying and then writing our answer in the form of a plus bi. So we are distributing here. Negative 1/2 I times 24 would be negative 12i. Negative 1/2 I times negative 18i would be plus 9i squared. And remember from our vocabulary at the beginning, I squared is equal to negative 1. So this would be negative 12i plus 9 times negative 1. So all we did was substitute I squared and negative 1. So this would give us negative 12i minus 9. And to get it in the form of a plus bi, our answer would be negative 9 minus 12i. All right, for this next one, we're going to have to distribute a little bit. So we're going to have 2 times 5 is 10. 2 times 6i is 12i. Negative 3i times 5, it would be negative 15i. Negative 3i times positive 6i would be minus 18i squared. Okay, so we need to combine these two like terms and then substitute I squared for negative 1. So we're going to have 10 minus 3i minus 18 times negative 1. And when we do that, we're going to have 10 minus 3i plus 18. And when we combine like terms, our final answer is going to be 28 minus 3i. All right, to square this, be careful you don't distribute a squared. No. We are going to write it twice to be safe. So 2 minus 5i times 2 minus 5i and distribute. So 2 times 2 is 4. 2 times negative 5i is negative 10i. Negative 5i times 2 is also negative 10i. And then negative 5i times negative 5i would be plus 25i squared. Next, we need to combine like terms with our i's and then change out I squared for negative 1. So we're going to have 4 minus 20i minus 25. So I kind of skipped a step. Hopefully you can see that this would be 25 times negative 1. And then when I combine like terms and rewrite it in the form a plus bi, I'm going to have negative 21 minus 20i. All right, last one. In this section, we're going to do 5 times 5 is 25. 5 times 7i is plus 35i. Negative 7i times 5 would be minus 35i. And negative 7i times positive 7i would be negative 49i squared. And so we need to combine like terms and change out I squared for negative 1. So that's going to leave us with 25 plus 0i. You notice these cancel out to 0. And then plus 49. And we get, can't do that in my head, 74. So notice here, if we were to write this in a plus bi, we could just write 74 or 74 plus 0i. Now this part right here, this problem right here is very important for what we're about to talk about, which is the complex conjugate. So let's scroll up here to our vocabulary. And the complex conjugate is best described if a and b are real numbers. Then a plus bi times a minus bi is equal to a squared plus b squared. Or in other words, there's no i's left. So the complex conjugate of a plus bi is a minus bi, which is a tool to help us down the road. So if we notice down here, this problem I squared in pink, we started out with 5 minus 7i, and then we had 5 plus 7i. Those are complex conjugates of each other. which is evident by our solution not having an I in it. Let me erase some stuff to clean that up. And this next section says, determine the complex conjugate of the following. So if we have 2 plus 9i, the complex conjugate would be 2 minus 9i. Square root of -3 is the same thing as I square root 3. And that's a little confusing because it's not in the form a plus bi. So if we did that, it would be a would be 0 plus bi. So the complex conjugate would be 0 minus I square root 3. Or just negative I square root 3. Awesome. So this helps us when we are dividing. So in order to divide with complex numbers, we need to multiply by the complex conjugate because we do not want any i's in the denominator. So in order to do this, first we need to determine the complex conjugate of the denominator. So for this one, that would be 2 plus 7i, and that will help us get rid of the I in the denominator, or the imaginary part of our number. We do not want to change the original problem, and so we need to multiply 2 plus 7i on the top as well, because this fraction here is equal to 1, so that wouldn't change anything. And then we're going to do a bunch of distributing. I'm not going to draw the arrows because it'll get really messy, but we're going to be doing distributing. On top, 5 times 2 is 10. 5 times 7i is 35i. 6i times 2 is 12i. 6i times 7i would be plus 42i squared. In the denominator, we're going to have 2 times 2 is 4. 2 times 7i is 14i. Negative 7i times 2 would be negative 14i. And then negative 7i times positive 7i would be negative 49i squared. In the numerator and denominator, we need to combine like terms and convert our I squareds to negative 1s. So in the numerator, we're going to have 10 plus 47i, and this would turn it into minus 42. And then in the denominator, we're going to have 4. Our i's cancel out like we wanted to. Those go to 0. And we're going to be left with plus 49. We need to do a little bit of combining. And so in the numerator, we're going to have 32 plus 47i. And then in the denominator, we're going to have 53. We want to write this in the form of a plus bi, so it's going to look kind of weird, but we need to take this as a fraction and this as a fraction separate. So I'm off my page a little bit, but the best a plus bi form would be 32 over 53 plus 47 over 53i, where 32 over 53 is a, 47 over 53 is b. If we could simplify those fractions, we would, but we cannot, or at least I don't think so. All right, same thing for this next problem. We need to first determine the complex conjugate of the denominator. So this would just be negative 7i. Now technically just 7i would take care of it, but just for consistency's sake, we're going to multiply by negative 7i. We need to multiply that in the numerator as well so that we don't change the original problem. And when we multiply negative 12 times negative 7, we're going to get positive 84i. And then in the numerator, when we multiply 7i times negative 7i, we're going to get negative 49i squared. We're going to keep our 84i on the top. And then negative 49i squared will turn into positive 49 because I squared is negative 1 times negative 49. And that is really all we can do, I think. Oops, nope. Okay, so 84 over 49 can simplify to 12 over 7. So if we really want a plus bi, we don't have any a. So we would do 0 plus 12 over 7i. And all that is 84 over 49 simplified because they can both divide by 7.